everyone, I'm Aishwarya. Welcome back to the channel. In this video, we are diving into one of the most important concepts in databases, transactions and their properties, also known as asset properties. Let's make it simple. So, what is transaction? A transaction in a database is a sequence of operations performed as a single logic unit of work. Think of it like transferring money from one bank to another. So in this video, we'll cover the asset properties, concurrency control and recovery techniques. Understanding these concepts is crucial for building reliable systems. Why transaction is important? Transaction help keep the database consistent even in case of system failures, crashes or errors. Let's move to the asset properties. So first property is atomicity. Atomicity ensures that the transaction is treated as a single indivisible unit. Either all changes are applied successfully or none are. If any part fails, the entire transaction is rolled back. This prevents partial updates. Let's move to the second property of asset, consistency. Consistency guarantees that the transaction moves the database from one valid state to another. It follows predefined rules and constraints. This property ensures data integrity. Invalid transitions are prevented. Let's move to third property of asset, isolation. Isolation ensures that the concurrent transactions do not interfere with each other. Each transaction appears to run in isolation. This prevents read-write conflicts and data corruption. Different isolation levels exist. Fourth property of asset is durability. Durability ensures that when a transaction is committed, the changes are permanent. We cannot change. The data is safely stored even in case of system failure. This is achieved through backups and transactions logs. Committed data survives. Let's move to the concurrency control mechanism. Concurrency control mechanism is basically manage access to data resources. Its goals is to maintain data integrity. Locking protocols are a common method. Time stemming is another approach. Optimistic concurrency is also used. Let's move to locking mechanism, shared and exclusive locks. Shared and exclusive locks basically. Shared locks allow multiple transactions to read concurrently. Exclusive locks prevent any other transaction from reading or writing. They ensure data integrity during updates. Proper lock management is crucial. Let's move to deadlocks and their prevention in transaction. Deadlocks and their prevention is basically deadlocks occur when two or more transactions are blocked indefinitely. Each is waiting for other to release a lock, and other one is waiting to release the lock. Prevention involves resource ordering and timeout mechanism. Detection and resolution are also important. Let's move to recovery techniques. Rollback and redo. Rollback undoes the change made by abort transaction. Redo reapplies changes from committed transaction after a failure. Both are essential for database consistency. Regular backups are also critical. Transaction management in SQL. SQL provides commands for transaction management. Begin transaction, it starts the transaction, commit, save changes, rollback, undoes changes. These commands ensure data integrity in SQL database. So, real life example of transaction is online banking. We transfer fund involves debiting one account, crediting another. A transaction ensures both operations occur or either preventing loss of funds. Consider a bank transaction where money is transferred between accounts. The transaction ensures that if the debit is successful, the credit must also succeed, and vice versa. So, let's conclude this topic. Transaction with asset properties are crucial for reliable database system. It guarantees data integrity, consistency, reliability, and across various application services. Transaction is important for database. Thank you so much for listening me.